Well.
Okay. Now we're live.
Then we just go check, check, check. Boom.
Good. Today is the first day for the countdown until I get my license.
Okay. So like
November 19th.
Is that your 16th birthday?
No,
you're
I'm
older.
16th.
Yeah, I was gonna say you're older.
It's just it's all messed up with COVID, but I'm still excited.
That's what I'm talking about. Are you gonna have a car?
Yeah, I have a car. I've had a car.
You already have a car? You don't have a license?
I know. I've had because my dad found like a super good deal, and he's like, "Well, I'm gonna hop on that now." And like I've had a car for like 2 years and like no license.
What type of car is it?
4Runner, 2005. It's pretty.
Yeah,
good.
you know. Did I tell you I have a 4Runner?
You have a 4Runner?
Yeah, I got a lifted 4Runner that I bought and built out to live out of like a handful of years ago.
So one of the cool ones.
It's one of the cool ones. It wasn't like van life per se, but it was manageable. Like
you could van life if you wanted to.
I lived out of it for 5 months while teaching.
So you were one van life.
Yeah, I was pretty. I think I was van life. I also had pet hedgehogs with me at the time.
That hedgehog?
Yeah.
That is so awesome. I've always wanted hedgehogs. What goes into taking care of a hedgehog? Is there
It's an
anything
amazing question. I could literally talk about this for the next hour. We could just drop math.
Yeah.
No, they're amazing because they're like very observable pets.
Yeah.
It's like I have a dog now that just loves me and is all over me at all times. With the hedgies, they don't really care about your existence, which is kind of like a nice detachment because you can set them up in their little cage and watch them run around. They were twin sisters, so they like had each other. It was cute. I've got some pictures and stuff. I'll show you. They're adorable. Henrietta and Hazel.
Are they actually like really sharp, or are they like kind of sharp? Or is it like prickly?
So you could I could grab a quill and poke you with it, but they have control of laying their quills down soft, where you can literally brush your fingers through them either direction, or they have like stage 1 where the quills kind of do this, or like stage 2 where they go like this. Or then there's like stage 3 angry when their quills crisscross.
Oh, so there's like,
and you literally
so it's like double quills.
They're like everywhere, and when you hold them, it's like super sharp.
That's
and
crazy.
They just when they tense their muscles, their quills will get more and more like jagged. It's crazy.
It's kind of sick.
They don't shed like porcupines though.
Well, anyways,
how's math class?
Pretty good. We're in a new unit.
That's what I'm talking about. So, is it not geometric proofs?
Not no more.
Okay, I can update this. Okay. What is it going to be?
This is parallel and perpendicular lines, mod 3.
Nice, so it's perfect.
Which is actually pretty good.
I should probably know how to spell parallel, right? Did I get that right?
Yeah, let's double check.
Parallel and
perpendicular. Nice. Perpendicular is a big word.
And now you can say it and actually know what it means.
Perpendicular.
All right, that's our thumbnail. All right. I like these packets. It seems pretty organized.
Oh yeah, I love it when it's just all the things are in one packet, in place. Okay, so I was just doing some definitions, and then this is where I left off. Identify the transversal and classify each angle pair. So 1 and 11, transversals H. So this stuff is pretty simple.
Oh, this is referring to this picture, I see, because you just did this one right here?
Mm-hmm. Yeah, that one goes there. And then 11 and 12, J. And then...
Just for fun, I'm going to draw this.
Yeah, no, I've kind of enjoyed this stuff. This and the constructions are definitely my 2 favorites.
Yeah, constructions are where geometry is actually fun.
Yeah.
It's like what you use it for in the real world.
Mm-hmm. Especially because I was thinking, I kind of want to be an architect. I think it would be a super cool job. So.
That's what I'm talking about. That's like a classic answer for a math teacher to be like, well, architects use math.
Yeah.
If you want to be an architect,
so
definitely use math.
They always say that. Damn, you got me.
No, I have to. Okay, so we just have this like triangle that's basically made out of 3 lines. And what's the word you're identifying right now?
Transversal.
Transversal.
It's like the line that intersects 2 lines. Or 2
so
other
I can spell that right. Yeah, I think that's a fine definition right there.
Yeah.
Transversal. So just give me an example of one that you answered here.
So we'll do the first one. Angle 1 and angle 11. So the transversal would be H, which is that one. Right there, like this line.
Oh, it's labeled.
Yeah.
Yeah, right. I see.
So that one's H.
Okay. Easy peasy. All right, and then you got your other ones. So 11 and 12's transversal
J.
is J here, did I?
Yeah.
What numbers did I just say? 11 and 12. Okay, yeah. And then what transversal for 9 and 5?
I.
9 to 5. That would be I, yep.
And then I again for 6 and 8.
8 and 6. Cool.
Okay. And then parallel lines, transversals. Parallel lines, transversal angle pairs formed are either congruent or supplementary. Alternate interior angle theorem. I don't even know if we touched on this yet. Do you know what this is?
This is way easier than the words make it look.
Oh, yeah.
You learned it, but you didn't learn it according to the words.
So alternate interior angles would be 2 and 8.
Probably. I think you said it so confidently that I just have to assume you're right.
Yeah, I just didn't. It's just the word theorem really like.
It's like the same thing as proofs. Like as soon as you call it a proof, it's like, no, actually, I don't want anything to do with this. You're like, but it's just basic algebra. All right. We have. I'm just gonna do the numbers here really quick. So we have 1, 2, 3, and 4, which are obviously not angle measures.
No,
they're just labels. 6, 7, and 8. They could just as easily be A, B, C, and D. Okay, so alternate interior angles theorem. Which one did you suggest?
I just did 2 and 8.
2.
Because they're on alternate sides of the transversal, which we could just say it's like A or something. Or no, it's J. And then this is I and that's H. But they're on the inside of H and I.
And I think that is a perfect way to describe it.
Yeah,
they're on the inside, so interior, they're on alternate sides. So then what's your next question they ask you?
Alternate exterior angles theorem, which is just the same thing except on the exterior of H and J or H and I. So I'll just say like 1 and 7. I think that works.
Sure. And there is some truth, some like we'll call it a rule, but it's I hate using the word law in math because it's not arbitrary law. It's not like designed by someone written down in words. It's more just emerges from the fact that you have two parallel lines, and when you have this transversal coming down, what's true about angle 1 and angle 7 relative to one another?
They're on either side of J.
That this is true. They're on either side of J. Let's say angle 1. Roughly, what is that angle right there?
Probably like a 120 maybe?
120. It's more than 90, right?
Yeah, exactly.
So like 120. So then what do you think this angle is right here?
It's 120.
120. So that's what the actual theorem is saying, is that there's this property. Property is way better than law. Let's go with property. Okay. There's a property that if you have a transversal cutting only through parallel lines, if these lines are even slightly off parallel, property doesn't work anymore. But essentially you get the same angle 1 and 7, and then you'll also see a similar truth with like 1 and 4.
Yeah, so with this it wouldn't be the same.
Yeah, these are just slightly off parallel.
Yeah, got it.
Which I literally think of this as like two edges of paper that if you brought them together, it'd be one line. And then as soon as you kind of spread them out, it's like the same properties, but just add a gap.
Yeah.
Kind of.
Yeah. Right. And then for the next one, same side interior angles. So H is on the same side of the transversal, so like 2 and 5 per se.
Okay, so
that's like same side interior angles since it's on the inside, you know. And then corresponding angles. That one's like 1 and 5, I believe. Corresponding.
Let's just do this.
Yeah.
More football as it goes.
Because they're on the same side of like each. They're like both on the. They're both on the left, and they're both on the same side as well. The transversal.
Were you right?
Yeah.
All right. There you go. Yeah, it's the rules of what's equal and what's not equal, and what adds to 180 and what adds to 90 and such. You'll start to get a very intuitive feel for, and you might eventually drop some of these definitions, but they are like the technical definitions of the properties that you're going to start to play with a lot in these lines.
Yeah.
What's true of like what am I doing here? What's true of like 2 and 6?
They're corresponding.
They're corresponding. What does that mean about their angle measures? The angle measure of 2 compared to the angle measure of 6.
I mean, so they're in this example, they're corresponding and congruent because we know the lines are parallel, but like they're not always congruent.
Congruent, and by congruent you mean
Like
the same
equal,
same measure?
Yeah, exactly.
So in what case wouldn't they be congruent?
If it was like if angle H was like angled like any differently.
Ah, right. So in the parallel lines case, you're saying that's true.
Yeah.
Okay.
But like, a lot of these two are still corresponding, but they're not congruent.
I see what you're meaning. So you're giving me the general case of what corresponding means, and here you're giving me the property of corresponding angles when they're paired with 2 parallel lines.
Yeah, exactly.
Okay, that's very specific. I like that. Again, that kind of like folding thing. If you folded H and I into one line, angle 2 and angle 6 would literally be the same, like
exactly.
Same exact angle right on top of each other.
Yeah.
Okay, cool. So now you have to write some of that stuff down.
Okay.
And you can start with the examples because that's where you are talking first.
2 feet. I just touched that. I probably made like a really loud noise.
It's a low budget film here.
Yeah, didn't you get all this like pretty much for free?
My room, yeah, it's my roommate's. Okay. So I'm liable to pay for it.
Yeah.
If I break it on accident, but yeah, as of right now, it's a nice gift of a loaner.
Corresponding to 6. And then he said we don't have to write down the definitions if we like can look at the example and like put 2 and 2 together.
Okay, there is one thing that you could write for each of these as like I don't know if you would write it in the definition or the example, but talk about the measure of those angles either relative to one another or in a different case where maybe you're talking about the measure of them if they were added together. I don't even know if we did that one in here though. I think we did all. So like for this one, for example, what is true for alternate interior angles of parallel lines?
They have the same angle?
They have the same angle. So the angle, I would write that like angle 2 equals angle 8 rather than just 2, 8.
Okay.
Right. So that's just like a one step further in your example or your definition to actually show why this is useful.
Okay. So would that, you think I'd kind of, if I just wrote that down in my definition?
You could write that in your definition. That's fine. Okay, yeah. It's probably better than nothing. And it's probably going to look similar for like something like 1 and 7, I think was one of your examples.
Yeah.
Then
you can't really do that with the third one.
So 2 and 5. Now this one is interesting though. 2 and 5 do have something special about them.
They add up to make 180.
Oh, boom. There you go.
So yeah.
Angle 2 plus angle 5 equals 180 degrees, which could be visualized any number of ways, like you ski, right? We've talked about this. So 180, you start forward and land backwards, and it's kind of the same here, but the turn that takes you to going backwards is on this like jagged path instead of a smooth rotation.
Yeah.
But it's still that like 180 degree rotation around. Or you could, go as far as to actually look at like, what are the chances that I can actually make this happen? Let's see. Okay, there's one. Just got to prove it since we're here. We said that and 2.
Yeah.
Right? All right. Now we got to take this bad boy.
You should get sponsored by this app. That's the goal.
I wouldn't mind. I do love this app. Let's see.
Yeah, it seems
Not bad.
legit enough.
There we go. All right. That's my visual proof.
Mm.
I'm going to get even faster with that in the future. All right. I think what they should do, and I don't know if I just haven't figured it out, there should be a way to like, I don't know, but for like lock whatever you've drawn on there, so then you can erase and draw on top of it without messing everything else up. But anyway, feedback. All right. That's not bad. We're going to start using that to solve like bigger drawings with lots of lines and angles together, something like that.
Yeah.
Oh, and they throw in the algebra.
Yeah, that's when it gets rough. But practice each corresponding angle. ABC. It's 180. Right?
We're doing this one here. Measure of angle ABC.
Yeah.
Yeah, so that's...
And if they're corresponding, and those two arrows represent like parallel, so we know they're the same.
So point to what letter should they use to identify this angle on here, this missing one, ABC?
That one? Ooh.
It's that little X?
Yeah.
So does that angle right there look like 180?
No.
Not quite.
Oh, no, I said 80.
Oh, you said 80.
Yeah.
Okay, I thought you said 180.
No,
I
no.
said 180. I thought you were like adding the 80 on or whatever. These are parallel. That's 80. What was the theorem called again?
Corresponding.
Sure.
Yeah.
All right, that one's easy.
So
80 it is.
simple enough.
I'm not even going to draw.
Yeah. And then this one's a little more complicated. So DEF. DEF. Okay.
You start to just think about it while I kind of draw.
We did a little of this today. I didn't really understand it. Anytime we see algebra, I just lose hope, but like, probably shouldn't do that.
You're going to be fine. I get even more excited. I love geometry, but
yeah,
I love teaching algebra because of that exact thing. People lose hope with it.
Do you think more people like algebra or geometry?
I think the people who don't identify necessarily as being strong with math probably, on average, like geometry more.
Yeah.
Because it's more visual and real.
Exactly.
People who do identify with being good at math probably tend to like algebra more because it's more problem solving and like you can get super like theoretical with it and just go crazy with doing algebra to solve things that don't necessarily have to have a real life connection. So
yeah,
I like them both. Calculus is my favorite. Calc is super fun and like very real, very, very real. All right, so we got D, E, and then F over here, and then they give us angle measures, but they're not just like angle measures, they're like equations almost. X plus 30 degrees, 2x minus 45 degrees.
Oh,
which looks weird, right?
I should have wrote this a little differently. I need to write them next to each other to like show they're equal.
So all right, you're already getting there.
2x minus 45. All right,
Okay.
So.
And they're equal, like, for the same reason, right?
Yeah, because parallel, congruent.
Sure. Okay. So now what?
Corresponding.
Now what? Now we're out of the realm of geometry.
Yeah. So now we need to. Do we start with getting rid of the x or getting rid of like the angles? Does it really matter?
Yeah, you could do either. My first step with an algebra problem like this is I typically ask myself, what am I looking for? What am I trying to solve for?
X.
X. Okay, so I'll come down here and I'm gonna write x equals.
Okay.
That's my end goal.
Okay.
So now how do I take this equation and slowly start to unravel it so that I end up with just an x on one side? You could do it from either side, but
yeah, we should start on this side.
Okay.
And get rid of 2, right?
so
Or should we get rid of 45?
Yeah, we could do either. The harder way would probably be to divide everything by 2.
Yeah.
Because 45 doesn't divide evenly
Mm-hmm.
by 2. You can do it. 45 halves is a number. It's 22.5.
Okay.
If you don't want to divide because I can't just divide one chunk of my side by 2. Okay, if I'm going to do something, if I'm going to affect this side of the equation, I'm going to affect the whole thing, then I'm going to equally affect
Yeah.
the other side. So what was your other option?
The other side?
We could do the other side, or what also could you do
You
to
could
this left side?
get rid of 45.
Cool. So I can just come in, I can add 45 to the whole side here.
Yeah.
And 2x minus 45 plus 45 is equal to what?
Wait, sorry, what was it?
What is 2x minus 45 plus 45?
But like, I thought you couldn't add, okay, 2x minus 45, that's a negative 42 or 43?
I know what you're doing right now.
44.
Right, you're trying to mix
43.
You're trying to mix the x's with the terms that don't have an x in it.
Yeah.
And that's fine. That's like a very common thought.
Yeah.
Right? The reason they're written like this to begin with is because a term that's being multiplied by x is not what we call similar to a term that's not being multiplied by x.
Yeah.
You also can't add it to a term like this because it's also not similar. You don't have the same amount of variables. We can go on a longer tangent on this, but it seems like we're going to do it a couple times coming up here.
Yeah, because isn't this like more theoretical?
This is solving using symbols.
Yeah.
Right, so it's symbolic, which is kind of like theoretical in a sense.
Yeah.
But it's going to come out to give us real measures. So maybe I'll just kind of move us along on the first one since we have like 6 left, and you'll be able to just keep practicing getting better. So you can add 45. Negative 45 plus 45 is equal to 0. Okay, and then 2x, if this makes you feel better, I could write it like this. How about we add 0x plus 45 to both sides?
0x plus 45?
Yeah, what's 2x plus 0x?
2x.
2x. And then what's negative 45 plus 45?
0.
0.
Yeah.
So do I really need to include the 0x?
You don't have to,
But does that kind of clarify? If I do it to one side and I want to maintain this equality,
you have to do it to the other.
I have to do it to the other side, right? Balance that teeter-totter out, so I will add 0x plus 45 again.
40, 50, so that's 75?
75 here. And then what's 1x plus 0x's?
That's 75. 1x plus 0x's is just x.
X. Cool.
So x.
So I'll just write this without the zeros.
Yeah. 2x equals x plus 75.
All right.
So now we get rid of the 2. Like divide 2x, right?
Yeah, we could get rid of the 2, and that would leave us with an x on this side, right?
Yeah.
And that's the goal.
Mm-hmm.
In our answer, though, do we want our answer to also include an x on the right side?
No.
So one way of kind of phrasing it, I like to say typically, is try to get anything with an x to one side and try to get anything without an x to the other side. Okay, so if we don't want to include the x on the right in our final equation, how can we move it to the left, or how can we cancel it out from the right?
So if you want to move 75, or move x.
We want to move this x over here.
Yeah.
In other terms, we want to cancel it out from this side. We don't want there to be an x anymore. There is one x.
Yeah.
So how do you get rid of one x if you already have one?
Minus x?
Yeah, you just minus an x.
Oh.
That's not bad. Right?
Okay, but then you have to do it to that side?
You just have to do it to this side as well. And that's actually great because that's going to make our life easy here. What is x minus x on the right side?
X minus x is 0.
0.
So it's nothing, yeah.
Okay, and then plus the 75, right? I should do that in real pen, huh? So this is just 75. 0 plus 75. And then what's 2x minus x?
2.
If you have, give me something that could stand for x. Name an object that exists in the world.
A water bottle.
A water bottle. Okay, you have 2 water bottles. You get rid of 1 water bottle.
Oh,
how many water bottles do you have?
1x.
You have 1x left, right?
Okay.
And x is a thing.
Yeah.
We don't know what the thing is yet. So that's why it kind of stands in its own number space apart from a number like 45, which we know is exactly representative of 45 of whatever.
Okay.
But in this case, because we don't really know what x could be, it could take any number of inputs. That kind of comes back to why we're not combining here. We'll get more into polynomials in the future. I'm assuming they'll keep popping up. Why did I write this in two parts here? This was 1x equals 75. Or just x equals 75. So we got an answer.
So x equals 75. So 2 times 75.
Yeah, what's 2 times 75 up here?
2 times 75. What is 2 times 75?
Think of having 3 quarters, and then you now have 6 quarters.
6 quarters. $1.50.
150, right? 75 times 2 is 150.
Yeah. So
that's 150 minus 45. What's 150 minus 45?
150 minus 45. That's 105.
105 degrees.
And then so that's congruent.
And you can just check what's 75 plus 30.
75 plus 30. 105.
75 plus 30 is, and that's to be expected, right?
Yeah.
And also, does that angle kind of look like 105?
Yeah.
Right. It's just a little more than 90.
Mm-hmm.
Okay.
All right. I'll write it down.
Yeah, nice to check yourself at the end when you get an answer from an algebra problem, because it kind of brings it back together into the real world.
So x equals 75. And that means that DEF equals 105.
Cool. And that was our actual question, right? Not what x was, but what the angle DEF was, and that was 105. Cool. And maybe next time we do a problem like this, maybe we'll guess what the angle will be at the beginning, just so that when we finally go through all the work and then we get an answer, we can be like, yeah, that seems right. Or like, whoa, I messed up, definitely. Mm-hmm. Okay, what's next?
Next, practice with AIA, AEA, SSIA theorems. So, okay, I remember now. So alternate interior angles, alternate exterior, and then same side interior angles.
Yeah, that sounds right to me.
Yeah.
So they're already dropping the names in this packet alone from one page to another. They've moved to acronyms, so you can see how long you're going to have to actually like memorize these names. As long as you can look at it again in the future and be like, oh yeah, I remember what that's talking about. And that's enough. All right. Which one do you want to do? Let's just pick one. I'll leave.
Let's do this one.
Okay. We got some multiplication going on here.
Yeah.
So, you want to try to draw it?
Sure.
If you draw a line and then
right?
hold, yeah, you know. Okay, you know. Okay. Well, you're younger than me. You know for sure. Technology, man. I feel like.
Hey, straight line.
I used to be the one that people would be like, "Oh, you just know tech so well." I work with my 15-year-old students. They're like, "Wow, this world is advancing faster than I'm comfortable with."
Yeah. No, I'm like not even that guy. I'm not even that good. Some guys are insane. Let's call this tech. T. R. Oh, wait. Now my bad handwriting is big show into the world.
Couldn't you wish you could like hold down your letter for a second and turn it into like a nice letter?
Nice like Roman. Or Times New Roman. Okay. Cool.
All right, you get to control this one.
Okay. So.
And what are they asking?
Well, I guess they can ask. Okay, so this one's interior or same side interior angles. So. I'll write that down. SSIA. Boom. Same side interior angle.
And we know we'll have to get x, but what angle do they actually want you to solve for when it's all said and done?
RSU.
RSU?
Yeah.
Are you sure?
Well, RSU and TUS. Right?
Oh, and TUS. I don't think RSU is on here.
RSU.
But what measure are they looking for you to find?
Oh, TUS, yeah.
TUE.
Okay.
It doesn't really matter because we're going to find both.
Okay.
But just so you can take a guess, what do you think TUS could roughly
Honestly,
be equal to?
Close to the same as last one, like 105 or
Yeah,
something.
that's pretty reasonable.
Probably like more.
Okay.
I'll say 110.
All right, we'll go with 110 just as a vague guess for now, but we'll come
Okay.
back and check it.
Yeah.
All right, so what's the setup here?
So, should I like make room or something?
Yeah, you can do this little guy here and then circle this all.
Okay.
And then once you circle it, just tap on it and then hit resize.
Resize.
Yeah, grab the bottom corner. Oh, I just messed you up, sorry.
Okay.
Try again. Grab the bottom corner and make it like half the size. And then you can
Tap. Resize.
Yeah, and you can like slide that up in the corner. Gives you a little space.
Oh yeah. Okay, and then now back to the pen. Which one do you use?
It's this one right here.
Okay.
And you're on white's good.
Whatever. So where do I start? I start. Well, so these aren't equal, but they're equal to 180.
Mm-hmm.
So 13. 13x plus. I did that weird. Doesn't matter if I write that down.
The angle, no. As long as you know that the unit is degrees once it's all said and
Yeah,
done.
okay. Okay, this is bugging me. Is this the eraser? Yes. Okay, so now I want to get rid of this x, or just one of the x's?
We know that we're going to want anything with an x in it on one side of our equal sign.
Yeah, which we already have.
Which we already have. Anything with that on the other side. So now that you have that, you can combine like terms. So if you have any two terms that each include just a single x,
You can combine them.
you can combine them by their coefficient. You're going to have 13x's here, 23x's here,
So
combined
36.
together, 36x's, right?
36x. So, and then is equal to 180.
Equals 180.
So this one actually seems pretty simple.
I think you're going to get this one.
So 36x is equal to 180. So then we get rid of the 180.
Let's.
Or we get rid of the 36. So,
Yeah, we want to get the x by itself.
Okay, so would you divide this by 36?
Divide that side by 36.
So you divide this. Okay, so
Divide the other side by 36.
divide by 36. So this is just x equals. And then I don't know this one. Do you know this in your head?
Let's just take a quick guess.
36.
Let's try like maybe 30. How many times does 30 go into 180?
Like 4 times?
3, 6, 9, 12, 15, 18. So then 30, 60, 90, 120, 150, like 180-ish.
Okay, so like 6 times.
About 6 times if that was 30. It's not quite going to go in 6 times though, because
Yeah,
this number is
because
bigger than.
Okay.
It's roughly going to be
6.
5 to 6-ish. But we can use a calculator really quick. 180 divided by 36. You can just type that right in there.
Okay, so 180 divided by 36. 5.
5 on the
good.
button. Cool.
You got it. Okay, so equals 5.
X is equal to 5.
X is equal to 5.
X is like this teeny tiny skinny piece of pizza.
Yes.
That's 5 degrees at the point. And if you put 36 of them together,
You get 180.
you'd get a semicircle.
Okay.
Exactly.
Oh, okay, that's a good way to think about it. So now now that we're trying to get to, okay, so 23 times 5, which is, let's get that calculator out again. 23.
I highly promote calculator use in my
Yeah.
classroom. If it helps you solve a bigger problem.
Yeah. 23 times. Is it 23?
23 times 5.
115.
15. Maybe one day I have plenty of strategies for helping with mental math that makes it
Yeah.
easier, but
So
I'm not trying to add too much at once.
Oh my god. So. Okay, yeah. Is equal to TUS.
Boom. Nailed it.
Cool.
That's it. And we guessed 110, I think.
Oh yeah, we
You
did.
guessed 110, 115.
Good guess.
Not bad, huh?
Okay, so I hope this doesn't look like I'm cheating.
Why would this? Oh, because you're over here.
I
Well, you have proof.
Yeah, I got video
You
evidence.
thought
I have
through
video
this.
evidence.
If teachers sometimes do get frustrated when students get tutoring, because it's like, well, the tutor just gave you all the answers. It's like, well, I think they did some really critical thinking over that hour, and that helped them get answers
Yeah.
because they got the guidance from the tutor. It's not like, I don't know.
And it's
just learning more.
because usually you like write it down on your homework.
Yeah.
too.
And then suddenly it's not cheating if the teacher teaches it to the student and then they know how to do it.
Yeah.
But if a tutor does it, then I'm a teacher. I'm not actually jaded. I have heard the feedback occasionally though. All right, let's pick a complicated one. This one looks pretty crazy here.
Yeah. Okay. So same theorems.
Yeah, here,
I'm
I'm gonna
X and Y.
start to draw it out because
On
this
the
is quite
diagram. Yeah, this one's different too because it's not like equal. Or it's like different. You know what I mean?
They almost look parallel, but they're not quite.
Yeah.
I'm gonna try my best to draw that.
Find X.
So start to work through this one slowly, just on your end. And try not to distract you.
Okay, so do you think that we could just do this normally and then like subtract 5 or something somehow?
Like assume they're parallel and then just like adjust it.
And then adjust it because they're only 5 off. Like that would work, right?
It's an interesting thought, and I think it depends on exactly what you'd be aiming for. But I think what you're overlooking is that you actually do have 3 parallel lines on this.
Oh, okay.
Right? You do have that relationship to work with. It's just in a kind of rotated orientation of what you're used to seeing. Maybe we'll revisit that question and see if it makes sense once we get our answer.
Okay.
But looking here, you do have the 3 parallel lines, and what are they asking for again?
X and Y.
To find x and y, right? So not even to find an angle, but to find whatever x and y are in this case.
Yeah.
Okay. They give us some information. Does my diagram, just make sure I'm not going crazy here, does that look right to you?
I think that's good, yeah.
Okay, cool. All right, so what do we know?
We know 55 is equal to 5x minus 4y. And then 60 is equal to 5x minus, or plus 5y.
Yeah, perfect. Besides this, just a little smaller. So you just said that 55 is equal to 5x plus 4y. And why is that, just for clarification's sake?
Why is that?
Yeah, like where did you glean that from?
Okay, because 55 and that equation is like complementary or corresponding.
Corresponding, yeah. That looks just like a problem you were doing before, right?
Yeah, because these lines are parallel, or these lines are parallel. So.
Exactly. It's just kind of like a two-parter here.
Yeah.
All right, so 55 equals 5x plus 4y, and then you also said that
60 is equal to 5x plus 5y.
Cool.
So I guess we should do one at a time, right?
Yeah, we could do one at a time. Well, you do have 2 variables in each equation, which means we will necessarily need 2 equations to solve for it. But just really quick before we jump in, let's assume x and y are some small positive numbers.
Okay.
We're not sure what they are yet, but 5 of the x's and 4 of the y's will combine to make 55.
Okay.
And then 5 of the x's, 4 of the y's, and then just 1 more y will combine to make 60.
Yeah.
So right away, without even really using algebra to its fullest extent, what can we probably say about the value of y? if adding one y brings us from an angle of 55 to 60?
That's one less. That y is one less. Right?
There's one less y in this.
Yeah.
And what does it make a difference of? What's the difference between
5.
a 5?
So can we assume y is 5?
Y is probably 5. I'm going to write that at the bottom corner. Let's solve it the traditional way. But sometimes equations are just obvious and you can be like, oh, well, it's literally the same equation except for 1 additional y and 5 additional degrees.
Okay.
But let's see if we can solve it just by hand and see where that gets us. And this is going to be, this is solving a system of equations, which if you were kind of 50-50 on solving a single equation, then a system can sometimes be confusing.
Mm.
Have you done that before where you solve for one variable and then plug it into the other equation?
I don't remember doing it.
Okay. Let me just run through it one time,
All right.
and then this is a hard problem. We'll probably address this again and again in the future. Probably go about solving this problem. No, let's do elimination. If you haven't used either form, then let's use the one that's easiest on for this problem. And it's literally to take it's elimination. You take your two equations and you literally subtract them from one another. And in fact, let's do it.
Okay.
Let's do it in the opposite order. Since I'm setting you up for perfect success anyway here, might as well make it super easy.
Yeah.
So you take your two equations, we're just going to subtract them from one another and get a new equation. That's just as equally true. So what is 60 minus 55?
5.
5 is going to equal, what's 5x minus 5x?
X.
If you have 5 water bottles and then you get rid of 5
is it
water
2,
bottles.
2x? Oh, okay. 5 water bottles and you get rid of 5 water bottles. It's just nothing?
It's nothing,
Yeah.
right? You have 0 anything left, right?
Okay.
You got rid of everything. So that's a 0. And then what's 5y minus 4y?
1y.
Okay, what's y equal to?
Y is equal to 5.
5. Isn't that what we just said?
Yeah.
Down below. That was like one of the worst 5s I've ever drawn in my life. All right, so that wasn't that hard. That's a process called elimination. If you have two true statements, you can add them and subtract them together. It's going to make another true statement as long as you do the proper math, like the proper arithmetic here.
Yeah.
And if you do it with like a purpose, I did 5x minus 5x on purpose because I knew it would cancel out and get rid of my x's. This is like an end of algebra 1, beginning of algebra 2 technique.
Okay.
Okay, so you either learned it at the end of last year or you're going to learn it next year.
Yeah, that was like weirdly easy. I was totally bugging about this.
Yeah.
It's just
Substitution would have gotten us the same answer. It would have just been like
like
a lot more math.
stuff.
Anyway, we're in geometry class. We don't have to worry about that too much. But we know y is 5, so you can take over from now. If we know y is 5, also my eraser little tool came back and started working again.
Okay,
Isn't that
so
cool?
double click.
Yeah, it like stopped working for
That's
forever.
nice.
We know y is 5.
Yeah.
What is x?
X. Okay, so we should. Could we use the same like format?
In fact, you only need one of the. You can choose which equation, but you only need one.
Wait. Oh, okay. So can we like change this to like would we need to change the subtraction, or would we keep it subtraction?
Yeah, and you're confused because you haven't seen this technique before, right?
Yeah.
We had to use two equations at once
Yeah.
because we had two variables that were each unknown.
Okay.
Now that we know one of the variables, how many unknowns do we have?
1.
1. It's x. We don't know. We know y. We can plug in for it,
Okay.
but we don't know x. And if you only have one unknown variable, you actually only need one equation to solve it. So pick. Do you want to use this equation or do you want to use this equation?
Guess we'll just use the 55 one or 60.
Either one.
Yeah, we'll do the 60.
Okay, so go ahead and just write that maybe like here off to the
Okay.
side. So 60 equals 5x
Or could
plus
we
5y.
could we just
Oh, yeah,
like,
you can.
just move all this?
Yeah, I like that.
Tap. Resize. Short. 6. Then back to this. Okay, so now we're just solving.
We're solving, right? But there's something we know
Oh, okay,
now that
okay.
can help us.
Okay, so that's 25?
25. 5 times
Okay.
5.
Yeah. Oh, I just
So-
did that on accident.
You did that
I
on
really
accident.
wanted to. Okay, so then 5x plus 25. Right?
Yeah, that's looking good. 60 equals 5
5x.
times whatever x is
Yeah.
plus 25.
So we should get rid of. Or could we should we get rid of 25? I think we should.
X's to one side, numbers to the other. That sounds like a good strategy.
Okay, so minus 25. Minus 25.
Your hand can sit on the screen, by the way. Makes your life easier.
Yeah. I wasn't sure if yeah.
Then you just start drawing handprints everywhere like turkeys.
Okay, so this just cancels out, and then do the blue thing, and then what's that? That's 35. Yeah,
35.
30. Oh my god, I'll just do it. 35 is equal to 5x. So
close.
okay, so now we get rid of the 5, or do we get rid of 35? Well, that wouldn't make sense if we got rid of 35.
Yeah, you do want to keep one x around. In fact, that's the end goal.
So
is to end up
so
with
minus 4?
You so you're thinking of
Really?
subtracting 4 x's?
Yeah.
Yeah, you could subtract 4 x's and that would leave you with an x on this side, right?
Yeah.
And it would leave you with 35 minus 4x on this side.
Yeah.
And then suddenly you'd have an x on both sides.
Okay.
Then you'd have to undo it by adding 4x to both sides. It'd kind of be circular.
So I should divide this?
Divide by
5.
5, right? You have
Okay, so
5 of these little pizza slices. So we divide by the number 5, and that'll leave us with one single
Okay,
pizza
divide by
slice.
5, which is x, and this divide by 5 is, I don't know this one.
Yeah, you do.
You know
Just
this
kind of 5, 10.
10, 15, 20, 25, 30, 35. 7.
7.
Okay. So 7 is equal to x.
7
5 is
is
equal to
x.
5.
Probably.
So now I forgot what we're trying to find. What are we trying to find? Just these angles? Just both of them? I
It
guess?
says in the problem.
Yeah, okay.
No, it says reading the problem.
Just find x. Oh, we're already done.
Yeah, you did it.
Okay.
Right, we could if we wanted to.
Yeah,
I mean,
like figure those out.
what is 5 times 7?
5, 15, 20, 25, 30, 35.
35. And then what's 4 times 5?
5, 10, 15, 20, 20.
20. So what's 35 plus 20?
35 plus 20 is 45, 55.
55.
Okay.
Right?
Yeah.
Okay, and then let's just do
Oh,
the
they're
same
literally,
thing.
yeah. So we knew the whole time.
Yeah, we knew the whole time. It was 55.
Oh, yeah.
That's how you solve for, that's
Which-
how you
okay.
kind of formed the plan to solve for x in the first place.
Okay.
Cool.
Cool.
All right.
Shall
We're flying.
Shall we move on?
Yeah, let's see what else is in this dictionary of math that you've got
Yeah.
going on here.
Let's see. L and M. Wait, is this like a proof? Wait. Angle measure 1 is equal to measure 3. Yes.
That is true, assuming what's true about L and M.
That they're parallel.
Parallel, there's the word, right? Parallel, right? Parallel, perpendicular.
Parallel. Perpendicular.
Cool. Yeah, if they are parallel. So what I would do is I would just draw a little arrow there, and then turn it in and be done.
Yeah. Simple enough.
Unfortunately, they want you to use these postulates, little baby theorems, and the given information to show that L is parallel to M.
Okay.
So they're telling us
So they're telling us these two are equal,
angle 1 and angle 3 are equal.
which proves this, that these two are parallel. Right?
Does it necessarily prove it? Let's think. 1 and 3 are the same. Yes, I believe so. I understand now. Use the converse. Use the converse of the corresponding angles postulate. We need a reference where that shows up. I'm confused by what that means.
Yeah, me too.
Use the converse of the corresponding angles postulate.
What is converse supposed to mean?
Here it is. This is what we're missing.
Okay. Converse corresponding angles there. I think this calls for a Google.
My thought, just preliminarily, is that it's basically using rather than using properties of the graph to make like a statement about a proof, it's using a proof to make a statement about properties of a graph. Converse, or like the backwards order.
Okay.
But let's just type it in and see. Converse shoe manufacturing company. Corresponding angle theorem. All right, let's see here. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. If two lines, and here, go back to your other picture so we can compare it.
This one?
Yeah, this one here. So if two lines and a transversal, which one's the transversal?
That one.
Yeah, right there. Form corresponding angles that are congruent, then the lines are parallel.
Okay.
Which is the converse of the converse, being the original, says that
Two lines.
if two lines are parallel and crossed by a transversal, then the corresponding angles are congruent.
Okay.
Same thing, right?
So if you flip it, it's the same thing as what it's saying?
Right. It would be like saying, let's say that we took this piece of information here
Yeah.
and put it in for this, then you would know that this is true.
Yeah. Okay.
Likewise, if we're looking at this as the true information, then we can assume that this is also true. So the proof is just going two ways.
So could I just say converse?
Yeah, I'm not sure exactly what they want you to write there, because it's...
Proof's right there.
I mean, that's the definition. Perhaps they want you to use the definition. If angle one...
I like your idea of just putting the two lines.
It almost works. Let's look at this one. This one looks a
Yeah.
little more interesting.
So
this one looks like
measure
it should
7
prove something.
is that, and then measure 5 is that.
And x equals 13.
equals 13.
This is going to be way more rich.
Yeah.
Okay, so we did just draw that. So go ahead and start brainstorming how you're going to prove something using that information. We're trying to prove,
So this is,
ideally, that these are parallel.
you don't even have to do algebra in this one.
That's a little more plug and chug, huh?
Okay.
And they're telling us that 7 is equal to 4x plus 25. They tell us x equals 13.
$32 plus 25. So that's what I have so far. And I don't know how I can use that to...
I feel like you got that by actually calculating.
Yeah.
And then you forced that because you saw it wasn't working out right.
Yeah. That's pretty much what happened.
I can see behind the
I
scenes here.
got like... I forgot what I got. It was like 45 or something? Or like... No, it was like 57.
Yeah, 52 probably.
52.
I think you got 52. And it makes sense. You're close to getting it right. It would help to like write down your work, as every teacher always tells you forever. And you're like, stop, I don't want to hear it.
Yeah.
You just forgot to add the 12 here and the 25 here. Those are a part of the expression. You did 4x and you did 5x, but you want to do 5x or 5 times 13 plus 12, which is 65 plus 12, which is 77. The true measure of this angle is 77. That was a part of the original, this little piece here. And then similarly here, 4x or 4 times 13 was 52.
Yeah.
What's 52 plus 25?
62, 72, 87.
Close. Try again. 52 plus 25.
Oh my god. Excuse me, what am I doing? 77.
77.
77.
Right, you were just off by 10.
Yeah.
So 77 in both these cases. Both of these angles are 77. Does that look like a 77 degree angle?
Yeah.
A little less than 90.
Yeah, seems legit.
Right, it's just a little less than 90. So all you didn't realize was that was there. The 25 and the 12.
Okay.
And it would have helped if you just, were writing it down as you went.
Yeah.
You're good. So this one, if x is 13, are these angles the same? Are they corresponding?
Yeah.
So if they're corresponding, then what's true about L and M?
They are parallel.
They're parallel. Yeah. So maybe that's all you need to write. Because angles are corresponding,
Okay.
then L and M are parallel.
Okay. I'll Okay.
You can catch up on this if you want. If you want to write this down to solidify it.
So where's your phone? Okay.
All right, we got a couple minutes left. Let's maybe go through your packet and pick one more you want to talk about.
Yeah. I should have figured that out. Okay, we just did that. Should we just talk about this
Yeah.
theorem? Because I was still a little confused on that.
Yeah, fine. Let's go for it.
Okay, converse of a theorem. The converse of a theorem is found by exchanging the blank and blank. The converse theorem is not automatically true. If it is true, it must be stated. Okay.
That's a postulate.
Postulate.
Postulate's like I said, like a baby theorem,
Okay.
or it's more like an extension of a theorem. It's
Postulate.
like the little theorem that grows on the shoulder.
Okay.
Yeah. Or if it's super novel, you
It
can.
has a separate theorem. Okay.
Right. It's like a logical deduction that you could be like, yeah, this is probably true, but then you have to go through some pretty rigorous work to actually prove it. So what are some words that might be able to fit into these blanks?
Okay, and we're found by exchanging the x and y, maybe?
I like that idea, like the input and the output kind of.
Yeah.
Like rather than getting the output according to some input, you're actually noticing the output, therefore the input must actually be there. That's fine. There's another one. There's a couple words I could see going there. I think I know what they're trying to get at here based on the table below.
If then?
The converse of a theorem is found by exchanging
The if and then.
the if statement and then statement.
Yeah.
That's the same thing as input and output,
Yeah.
right? If this is true, then this will happen.
Okay.
I don't know. Maybe it says somewhere else in your packet better words. Here. Since this is our last thing, I'll just search really quick. See how to structure theorem if then. Let's see if anything pops up in that vein. Probably not. Well, let's just do this one more time. What was it? The converse of theorem. Oh, I spelled theorem. That's not right. Okay, now I'm going to converse of theorem. That's not what I wanted. All right. These are the words we're looking for.
Okay.
These are the words we're looking for.
Conclusion and hypothesis.
Yep.
So,
Conclusion being the then, and the hypothesis being the if. Yeah, and also, there you go.
If this. Okay, yeah.
If that, that's the easiest way to describe it. If this, then that. In the converse, if that, then this. Boom. I love it when big confusing things are simplified into like baby talk.
Yeah.
Cool. All right. So then for the converse corresponding angle theorem, if what is true, then what can you conclude?
That is true.
More specifically to this problem, start with just the normal corresponding angle theorem. What is the corresponding angle theorem? You can go back to your first page if you want.
Corresponding angle theorem is corresponding angle theorem. Oh, this is really corresponding angle theorem. Two angles that are congruent or on like the same side and everything.
Is that the if or is that the then?
That's the if. Or the then. Okay, so if they're corresponding, then they're congruent.
How about this?
This.
Just try again. I don't want to give it to you. Just try again, but include the word parallel lines in there and transversal, because that's an important part of this.
Okay, so if 2 and 6 are on the same side of the transversal, then they're corresponding?
Yep.
Okay.
If 2 and 6 are on the same side of the transversal that intersects two parallel lines,
Okay.
then they are corresponding, then they're congruent. They're equal, right?
Okay.
They're corresponding, but then that means they are equal. So in the other case, if you have corresponding angles that are equal on the same side of the transversal, then the two lines that transversal intersects, what's true about them? So we went from, there's a lot of words in this, but it's easy with the visual here. We said if these are parallel and a line cuts through them, then the two angles that are corresponding will be congruent.
Yeah.
Now, if we have two corresponding angles that are congruent, that lie on the same side of a transversal, then what's true of the two lines that intersect the transversal to make those angles in the first place?
They're parallel.
Then they're parallel, right? Parallel. We're literally like taking all these words and we're swapping like the first and last word almost.
And it like works.
And it's the converse.
Yeah.
Yeah.
Okay.
So now try to put that into 5 simple words as best you can, but it's very simply put, if congruent corresponding angles, then parallel lines. That's the converse.
Okay.
The original, if parallel lines, then corresponding congruent angles.
So if congruent?
If congruent corresponding angles.
If, I'm just going to say con and Parallel lines.
Yeah, that's the simplest way you could put it. You could probably go into more detail as you get better at this, but
Yeah, but actually, I think I understand it.
Yeah.
Well enough. Example. Would be a good example. Is it just this? I guess. This is what it wants me to do. I think. A. B. They're corresponding. I guess.
if A equals B, then L and M are parallel,
Okay.
or whatever you want to call those lines. So
So if A
if A equals B,
equals B or B equals A, then L M
well, that's like the two little. Yeah, but that goes in between L and M.
Oh, okay.
Notation. It's kind of annoying, but I mean, if you want to communicate this same stuff with people who say don't speak English, you can with the proper notation, right? Aliens, for example. I don't know. All right, we're done. How'd that feel? You good?
Pretty good.
All right, you got like a half a packet left. That's why I asked.
Yeah.
Sometimes I'm like hesitant that you're like, well, yeah, but we didn't finish my homework.
Yeah. No. I think I'm good on homework.
Very cool. All right. Do you have any tests or anything coming up?
No. We have one every Friday, actually, like a little quiz.
Oh, that's so like consistent testing.
Yeah.
So as long as you're doing tutoring once a week, you're golden. You're fine.
I'm sure. Yeah.
Bye. Screen record. Bye. GoPro.